I'm pleased today to present our pilot program that's a public-facing decision-making system for slope risk reduction. I'm Lingfeng from Beihang University, China. And originally, the title of my project is called a decision-making system for slope risk deduction. But actually, this system is we say is a public-facing. It's for all users who has a concern with the slope instability, who has a concern with say how to mitigate landslide. So this system is developed to support users, even who are not the expert in this field, to detect landslide early warning signs and to understand the slope stability conditions. And also, the system also helps to propose some professional and efficient stabilization measures to prevent the slope displacement. And next. So some people may wonder why I chose this kind of very specific topic. As you may know, landslide disasters are becoming increasingly severe worldwide, and with a rising frequency and scale. So this kind of activity are driven by multiple interacting factors like engineering constructions and global climate change and seismic activities, etc., etc., and leading to the significant loss of life and property. So I think we all know the significance of a landslide and also this kind of geohazards. So however, the public normally lack of a professional knowledge to assess the stability condition of the slope or to understand how to prevent further displacement on unstable slopes. So these challenges forms the rationale for the developing of a slope risk reduction system. It aims to receive, share, and transform multimodal Earth observation data, we say different types of Earth observation data, into actionable guidance for promoting landslide resilience. So this is kind of a challenges for the public to mitigate landslide, and also this is the rationale of our project. The next, our decision-making system integrates the yield data, the Earth observation data, and also the in situ measurements data, and also we can acquire online open access data, and also we are constructing a stabilization cases, a database of more than 500, even more. We have more data coming. Unstable slopes, we say the measurement, unstable slope reinforcement cases. And this system will deliver two major outputs. So the first one is a slope stability assessment. So this session is to monitor the deformation and to identify landslide precursors, like we know tension cracks on the slope crest, or slope surface subsidence or seepage. These are all precursors, we say the indicators of landslides or unstable slopes, and also estimate the slope stability conditions. So it is to estimate how stable or how unstable the slopes are. And second is a proposal of the stabilization measures. So this system can propose the stabilization measures from unstable slopes in reference to the landslide precursors we detected from, for example, the drone data, the drone images, or optical images taken by, we say, the citizens, and some other data altogether. And also we can estimate the instability degree, and also the local and the natural standards for the slope engineering, especially, and the most important one, that is in reference to the previous experience in slope reinforcement cases during, for example, a road construction engineering, because we have collaboration with national road construction companies, and then they can share this kind of key data with us and to better understand how landslide triggered along with the road construction. And these stabilization measures will be tested and we say validated in numerical modeling for the optimization. this is the kind of the main data and the services from our project. And the system, so we say the system will be open to the public. The users concerned with the slope risk management will be able to import slope related data into the system and export the key insight into the slope condition to support informed decision making. In addition, we are developing a spatial fabric, a data sharing platform. So based on this, the users across different regions, different countries are able to share the open data and also the sensitive data, and directly or indirectly. So this data can enrich our database and optimize the model performance. This data sharing platform is built on two core capabilities: the trusted authorization space and also the privacy preserving computation. So it allows the sensitive data, including the classified or security-related datasets, to circulate safely and controllably within the authorized security domains. So rather than being completely restricted from the transmission, and also at the same time, using the federated learning and other privacy-preserving analytics technology, so this system enables cross-domain collaboration between open and sensitive data without exposing any raw information. So this dual mechanism ensure data governance and also the security regulation while still unlocking the integrated and a multi-source value of the dataset held by different countries or different agencies because of the regulation of data. But so this is how we share the data with partners and also how we integrate the other users and get the data from them. And as we see currently, this program involves 12 organizations from nine countries across Asia, Pacific, Europe, and North America. Each partner has a clear defined roles in data supply and in computer vision-based algorithm development and also large language model development, and also especially the system application to increase the program impact and visibility. So this international partnership supports the long-term operational capability of the program. And recently, we just had an offline exchange forum with our Italian partner. So we discussed about the key data sharing of the multiple landslide cases in Italy. And especially like the mountainous landslide, also he has some data for the coastal landslide. And also we discussed about the plan of the developing a rockfall detection and trees prediction tool for the early warning of the landslide. And this collaboration are within the framework of the program. So apart from the current partnerships, we are seeking more international collaborations to promote our program. So our goal is to empower the users, even we say those without geotechnical, geological, or engineering experience. So to make informed decision about the slope safety, once users obtain the basic background information. So for example, once they have this kind of background information of the specific unstable slopes, and then they can upload the key slope photos, and then the system can assess the slope stability condition and also propose some reinforcement measures for this unstable slope. So this promotes the broad public participation in disaster mitigation and also enhance landslide resilience. So new technologies, generally, this system integrates several new technologies. For example, the computer vision-based algorithm to detect landslide precursors using remote sensing images. So these precursors includes, for example, the tension cracks, for example, the seepage, and also some kind of like a structure damage, exception. These precursors are indicators of slope instability and also could be used to estimate the instability condition of the slope itself. And also second new technology is a 3D slope reconstruction using optimized 3D Gaussian splatting. And we can have we say a cluster of stereo images. Then we use this advanced, we say optimized 3D Gaussian splatting to construct the 3D model of the unstable slope. So this slope could be used for the input data of the numerical modeling. And also we can fully understand what a slope it looks like. And also we can understand where is the precursor located on the slope and also in the slope, and what kind of precursor it is visibly we can check. So this is another part of, and third one is a multi-agent large language model. So it is capable of proposing stabilization measures based on engineering standard, based on a previous experience in slope reinforcement. So for example, and also in these slides, we showed up the milestones we have made. Although this is a pilot project, we also have some kind of advancement of this one. Me and my partners from Lingfeng University in China co-developed a tension quark detection algorithm. And then this module will be plugged into the system for risk assessment. And the next one is about the sustainability. So I will talk that around three aspects. The one is technical, and second one is organizational, and third one is the financial support. So the technical sustainability is supported by continuous data augmentation and also improved large language model generalization and also enhanced, we say, precursor detection algorithms. So we are optimizing this kind of technologies with is argument with increasing data dimension and also with our increased, we say, improved understanding of this kind of things. And also we have about the organization sustainability, we have more organizations get involved and they have their own roles in this kind of a project. So we can make sure that we have this kind of development is continuous. So and the third one about the finance. As you know, this project comes from we have partners from different countries. And for example, in China, from my side and from other side, especially from my side, I have got several funds from for example, from the university and from the company and also from the province. So this one could help me to support me to organize of a research and investigation activities, especially for landslide cases in China. And also we are helping our partners, for example, from Thailand, from Italy, to apply their national funds from their own country. So this is our plan as a pilot project. So in conclusion, this public-facing system democratizes the access to landslide knowledge by converting the complex Earth observation data and AI techniques into, we convert this kind of data into the practical guidance, the actionable decisions. So our vision is to make slope risk mitigation knowledge accessible to everyone and help community prevent landslide disaster before they occur. So thank you for your attention.